All right, Section B, 2016, problem number 11. This problem deals with planes primarily. Now remember, this is paper 2, so it's calculator friendly if you need it. It doesn't come in real handy. Well, it does a little bit on this problem. Okay, we got two planes. And the first part of this problem is find the cosine of the angle. Well, there you go. You got to go to your old formula packet. The cosine of the angle equals the dot product of the two vectors over their magnitudes, the product of their magnitudes. Let me take these bars off the top. We don't need those. Okay, so the dot product. Well, the vectors are the coefficients of x, y, and z respectively. So, and that's the normal vector to each plane. So the normal to the first plane is 4, 1, 1. And the normal to the second plane is 4, 3, negative 1. So all we have to do is dot those and put those on the top. And so when you dot, you just multiply and then add respective components. So 4 times 4 is 16, 1 times 3 is 3, 1 times negative 1. Add it all up. 19 minus 1 is 18. So that's what goes on the top. On the bottom is the magnitude of each normal. So 4 squared plus 1 squared plus 1 squared is 18. So that's the square root of 18. And the magnitude of the second vector is 4 squared. That's 16 plus 9 plus 1. That adds up to 26. So we got the dot product on the top and the product of the two magnitudes of the two normals. And now it's calculator time. Except, no, we don't want calculator. See, we want the answer. It says find in the form of the square root of p over q. Okay, so on the top we have 18. On the bottom we've got, I see another 18. So what I'm going to do is multiply. I'm going to rationalize the 18. So I'm going to multiply it by itself because I can kind of see ahead what will happen there. So if I put it on the top and the bottom, then I get 18 radical 18 over 18 times radical 26. See, I know my final answer is going to have two radicals, a radical on the top and a radical on the bottom. So I think I'm almost there because the 18s cancel, and then I've got a radical on the top and the radical on the bottom. P and Z are integers. You could leave it like that, or it is reducible by a factor of 2. They would take that answer, square root of 9 over 13. And that is the answer to part A. All right, part B says we have a line L, which is the intersection of the two planes. So those two planes that were in part A, let's say there's one of the planes. And I'm not going to draw the other one, but there's the line of intersection. So the other plane comes down and slices through that line. And we're trying to find the direction vector of that line. Well, if you think about it, remember that the equation of a plane has a normal, and that normal is perpendicular to the plane. So there's the normal. So the normal would have to be perpendicular to that line of intersection. Now that's going to be true for both planes. When that other plane comes through and slices through that line, the line that we're trying to find, line L, let me label that, will also be perpendicular to the other plane that slices through. Regardless of the angle, it's still going to be perpendicular. This is three-dimensional, so it's hard to see that, but that line will be perpendicular to both of those normals. So to find a line which is perpendicular to two given normals, what you have to do is do the cross product. So we'll do ijk on this. So ijk. And let's see, plane 1 was, it's back in the other part, but it was, let me write those down again. So plane 1 was 4x plus y plus z equals 8. And plane 2 was 4x plus 3y minus z equals 0. So the normal vector to plane 1 is 4, 1, 1. And the plane 2 is 4, 3, negative 1. Now this is always easy, except watch your arithmetic. And you also got to remember that j is negative. So to find this cross product, for I, you cover up the row and the column, and you cross and subtract. So if you cover up the row and the column, we got 1 times negative 1, which is negative 1, subtract 3 times 1, going in that direction. All right, for the j, negative, so we cover up that column, and we got 4 times negative 1, subtract 4 times 1. And then finally k, cover up that column, and we got 4 times 3, which is 12, subtract 4. So it looks like we end up with negative 4i minus 8j, but both of those are negative, so I'm going to change that to a positive. And then 8k. So there are the components of the vector, which give you the direction. So it says show that L has direction negative 1, 2, 2. Well, we'll write negative 4, 8, 8 as the vector. And remember, you can divide through by the same scalar quantity, which is in this case 1/4. If you take a fourth times this vector, it still has the same direction. So 1/4 of this is negative 1, 2, 2. So the line of intersection does have direction of negative 1, 2, 2. Part 2, show that the point 1, 0, 4 lies on both planes. That's actually pretty easy because if the point is on the planes, then that point must satisfy those two equations. So you just sub in. So we got first plane, 4 times 1 plus 0 plus z, which is 4, equals 8. Well, that checks. 8 equals 8. I guess we better show that. Now let's plug 1, 0, 4 into that second one, so we get 4 times 1 plus 3 times 0 minus z, which is 4, equals 0. Well, 4 plus 0 minus 4 is 0. That checks. So we are done with part I. Now write down a vector equation of L. Okay, let me erase some stuff here. It does not want to erase. Go away. There it goes, finally. Gee. It's kind of in slow motion. Okay. Write down a vector equation of L. A vector equation is in the form xyz equals, and then you put a point on the line. Well, it just told us that the point was 1, 0, 4. It's on both planes. If it's on both planes, it's on the line of intersection of the two planes. Plus some parameter. I like lambda. We'll use lambda. And then the direction, well, we found that in the previous part. So negative 1, 2, 2. And there you go. That's the vector equation of a line L. So part B is done. Part C of the same problem is worth 5 marks. It says, given the vector AB, well, first of all, we have to figure out what vector AB is. Well, we were given A in the previous part as 1, 0, 4, and point B is given up here is AB1. So vector AB, remember to find a vector, you just take the second x minus the first x and so on. So A minus 1, B minus 0, and 1 minus 4. So that vector is A minus 1, B, and negative 3. So there's vector AB, and it's perpendicular to that line L. Well, line L, its vector, direction vector from previous parts was negative 1, 2, 2. Now, since they're perpendicular, their dot product has to equal 0. So I'm going to set that up. Negative 1, 2, 2. Their dot product has to equal 0 because we're trying to find A and B. So taking that given information, this is the way to do it. Dot product, you just multiply and add again. So A minus 1 times negative 1 is negative A plus 1. Plus 2B or not. Plus negative 6 or minus 6 equals 0. So we have negative A plus 2B equals, well, it would be negative 5 to the other side makes positive 5. Okay, well, that's not enough information to find A and B at this point because we have two variables and we have to take some more information, and we know that AB1 is on, this is on plane 1. So we're going to sub that in to the plane 1 equation, which is, let me highlight it, it's right here. So let me come over here and write that. So I've got 4x, 4a, plus y, which is b, plus z, which is 1, equals 8. So I get 4a plus b equals 7. Okay, so now we have two equations with a and b, and we can just solve them simultaneously. Let me multiply this one by 2, or negative 2, and put it underneath here. So that's negative 4a minus 2b, or not, and negative 14. Whoops, negative 2 times 4 is negative 8. We call that arithmetic. Okay, let's add these two equations together and get what negative 9a equals. How nice. Negative 9. Oh, I love it. A is equal to 1. All right, so a is 1. Where's a nice place to put that? We'll just follow the arrow backwards. So 4 times 1 plus b equals 7. So it looks like b would be 3. So there is our answer for, well, that was pretty easy, 5 marks. Okay, now let me clean up things a little bit so we can do part D. Timeout. All right, part D is a 1 marker, so it must be pretty easy. Let's see what it says. Show that AB, meaning the length of AB, is 3 root 2. So all we have to do is find the magnitude of AB. Well, vector AB is right here from the last part, except we have to sub in our values for A and B. So we found that. A is 1, so 1 minus 1 is 0. B minus 0 would be 3, and 1 minus 4, well, I guess that's negative 3. All right, so that magnitude, we're going to use our magnitude, which is the square root of a squared plus b squared plus c squared, which is the square root of 18, which breaks down to 9 times 2. Kick out the 3. Done. There's the answer, 3 root 2. We done showed it.